Here we have this function x to the 4, and we want to find local max and min and also the inflection points. So first, to find local max or min, we need to find a critical point, and then we need to test these critical points to see if they are local max or min or either. We can apply the first derivative test or the second derivative test. Here I choose to do the first derivative test. So first let's find where is the critical points. So critical points is where the first derivative is 0 or undefined. So let's find the first derivative. So it's gonna be 4x cubed, and then let's see, is this undefined or not? This is actually defined for all values of x. So now we just solve this and equal it to 0. So a critical point will gonna be at x equal to 0. Now what we want to do, we want to test this critical point. So we're gonna apply the first derivative test to see if it's a local max or min or either. First step is to draw the x-axis and mark our critical points, and then I want to see the sign where is the first derivative is larger than our critical point and a value that is less than our critical point. So here I choose 1 and minus 1, so I'm going to plug these values in the first derivative. I want to see the signs there. So for x equal to minus 1, this is our derivative, and here 4x cubed. This is gonna be 4 and then minus 1 cubed. This will result in negative sign. And then when we take x equal to 1, it's gonna be 4 multiplied by 1 cubed. It's gonna be a positive number. So I'm gonna mark that on our x-axis. So we are going from negative to a positive and the derivative. So negative and then positive. So what does this mean? This means that x equals to 0 is a local minimum. Now let's graph our function f of x equal to x to the 4. This is an even function. It's gonna look like something like x squared. So here we note x equal to 0, and you can see from the graph this is a local min. So now what we want to do, we want to find the inflection point. So let's rewrite what is f of x, and then f of prime of x, and then f double prime of x. So a possible inflection point is where the second derivative of x is 0 or it is undefined, plus we need to do the test to confirm our inflection point is actually an inflection. So second derivative is 12x squared. Notice this function is defined for all values of x. So we're just gonna do equal that to 0 and solve for x. X gonna be 0. This is a possible inflection point. So to make sure it is actually an inflection point, we need to do a test. So what I'm going to do, I'm going to draw the x-axis in here. I'm going to mark our possible inflection point. I want to pick values that is larger than our possible inflection point and lower than our possible inflection points. I want to see the signs of the second derivative there. So first, we're going to do 1 and then we're going to do minus 1. These are just selected numbers, randomly selected. So for 1, gonna be a positive in the second derivative, and then at -1 the second derivative can also be positive since all squared. So we can see the signs of the second derivative does not changes. This means the first derivative is increasing. Therefore, x equal to 0 is not an inflection point. And you can see that from the graph too. So what do I want to say here? Not every time the second derivative equal to 0 or undefined, it's actually an inflection point. We need to do the test to make sure that's an inflection point.